Thanks, Jason. Imagine that you're at home, sleeping soundly, when all of a sudden you hear a noise. Oh no, the audio. Okay, there we go. So you're at home, sleeping soundly, you're not here, and then all of a sudden you hear this noise.
The network's down, it is
This noise is the sound of you getting paged. There's an incident in production. At Netflix, we're no strangers to this sort of thing, and in fact, over the last several years, we've seen a global increase in membership, where each of these members are watching more and more content every single day. And yes, China is missing, you can see there. But all of this content watching amounts to about 12% of all downstream internet traffic. This means that any amount of downtime is brutal and comes at an incredibly high cost to our members. The best way to visualize this is through this approximation, which looks backwards in time a few years. So it's saying that about 5 years ago, a 2-hour downtime to the Netflix service has the same impact in just 5 minutes today. As we continue to grow, we need systems and tooling in place that allows us to minimize this downtime or completely avoid it altogether. My name is Jeff Chao. Today I'll be talking about cost-effective, real-time operational insights. Or buzzwords aside, how do we understand what's going on in production without running up our infrastructure bill? Today's talk will be divided into 3 parts. First, we'll look at some of the realities and complexities of observing and operating microservices and how this led us to building and open sourcing a platform called Mantis. Then we'll look at some of the techniques that Mantis uses to get us these minimal costs without compromising on required and opportunistic insights. And then we'll bring all of this together and see what teams have built, what applications they built on top of Mantis to ultimately help them build and operate their microservices a bit more reliably. So, to start things off, let's look at some of the challenges and the realities we have to deal with. That's best understood by this map of the Netflix streaming microservices infrastructure. As you can see here, the circles are microservices, and the dots flowing between them are the traffic. Each of these microservices are independently owned and operated by completely disjoint teams, which typically don't have any control of their upstream or downstream dependencies. This means that it becomes really hard to coordinate and understand what's going on when there's a production incident or a downtime that's happening. As we continue to grow, it becomes even more important that we have access to rapid and precise insights, and as more and more microservices get onboarded, we should be very mindful of the cost of operating these types of systems. Because this image is actually several years old, so you can imagine that there are hundreds and hundreds more circles with a lot more dots flowing between them. For these reasons, we sought to build and open source a platform called Mantis, which is something that we often call a streaming microservices infrastructure, which helps us better understand the behavior of our applications so that we can ultimately build tools or applications on top of it that helps us build a more reliable service. Now, to get an understanding of the motivations behind Mantis and what it's all about, let's look at some of the characteristics and fundamentals of Mantis. First, Mantis makes it easy to answer new questions. The traditional on-call experience of working with logs and metrics, while still great and still useful today, they do come with gaps and at the worst times possible. For instance, have you all ever been in a situation where you're mid-incident and you had a hunch that you wanted to verify, a question that you wanted to ask of your system? So then you go into your index log search or your aggregated metrics in a dashboard or something, only to realize that you had forgotten to log this critical section of the piece of the code or forgotten to instrument your app with these metrics altogether. Well, what do you do in that case? You either try a different approach to validate your hunch, or you set out on this huge endeavor to make a code change, hotfix it into production, wait for the deploy to go out, and then wait for the metrics to be propagated and alerts to be generated, and so on and so forth. All of that takes time, and time which you don't necessarily have, because during an incident, every second counts. With Mantis, it works a bit differently. So instead of working with logs or metrics, we work with events, where these events, we encourage you to publish as large of an event as you can with as much context into the event as you want. The result is that these events could be hundreds and hundreds of fields wide, so that you could be able to pick and choose and derive insights from these events at a later time. That way, if you do think of a question that you want to ask in the future, it can be answered because the data will already be there available for you. And it will be there without having to necessarily instrument your application again against some metric or some log lines that you've missed before. The second fundamental of Mantis is that it makes these answers accessible with incredibly low latency. So if we take traditional metric systems as an example, it could take time to process these metrics. And at Netflix, a single application could produce billions of metrics per minute, and that takes time to publish, store, aggregate these metrics, and then eventually serve them to you in some batchy way over some window. So this batchy behavior is a little bit too slow for us, so instead with Mantis, it works in more of a streaming fashion where events are published and received and processed one at a time and served to you immediately or as fast as it can. That way, the batchy behaviors of windowing or aggregation, those decisions are put into the hands of the developers, in your hands, because as the developers, you know best how your application behaves and the semantics around that. Mantis, the infrastructure, has no idea how that works, nor should it care, as long as it provides you with the tools and the flexibility to do what you need when you want to. The third thing about Mantis is that it makes it very cost-effective to get these answers from your system. So if we take traditional logging as an example, ideally, in order to produce the most insight that you can, you would publish 100% of your logs all the time, all day. But this quickly becomes cost prohibitive at scale. And for example, at Netflix, a single app could produce 3 petabytes or 3 million gigabytes of operational data every single day for that single app. So if we set aside compression and compaction just for a simple argument's sake, you would pay this same cost over the network and on disk. And therefore, you won't have any money left to do anything else. So instead, some traditional systems help us get around this issue by filtering or sampling or some variant of that. Whereas you can see here, the shaded out parts, these log events have been dropped. But although you reduce the cost here, it comes at the price of losing some insight, because these events are already dropped at the source and they won't be available to you later on downstream to be able to use. And even with this, there are still issues with the single event themselves, because if you remember, ideally these events would be hundreds of fields wide and quite large in size individually. So traditional systems allow you to get around this is through projection, where you would select maybe a single field out of hundreds, in this case, a single status field. The issue with this is that you have to be careful that you make sure that you don't prematurely put yourself into this situation where you're unable to answer new questions later. Where, what if you're accidentally publishing only the status, but tomorrow you might want client ID with that, or a colleague of yours comes along and then they want the full fidelity of the event. Or maybe you just don't anticipate a question of your system today that you might later on a year from now. So you don't want to pigeonhole yourself into this situation that prevents you from asking new questions. What we really need is the true on-demand data fetching. And this is one of the things that Mantis uses to get insights while reducing the cost to get those insights. And it works like this. So Mantis has a reactive model or on-demand model where you're free to publish 100% of your events all the time. But the data doesn't flow and the cost isn't paid until something is subscribed to this stream. When something is subscribed, Mantis provides you with capabilities to select only what you need for that duration of your questioning. And therefore, you only pay a fraction of the cost as opposed to the entire cost of the event itself. The example here is it's selecting a single status field, but you can also select some other number of fields and do some other more interesting things that we'll talk about later. The second thing that Mantis does to reduce costs is aggressively reuse the data. As an example here, let's say that you have multiple people asking for the same or equivalent set of data from this stream. Mantis will recognize this, and rather than going all the way upstream to that application on your right or on your left, it'll just send that data that it has already on hand back down to these subscribers. So you save on additional network and serialization costs, and et cetera. The third thing that Mantis does is it gives you this native auto-scaling capabilities through efficient resource management. So Mantis will consume a bunch of signals internally and figure out whether it needs to scale out its parallelism or scale in its parallelism based on the workload that it has to accommodate at the time. The example here is there could be a number of consumers trying to read the data and then process them. All they do is just worry about the business logic, and then Mantis will take care of the resource management for them. So if I were to summarize the differentiators of Mantis, they're exactly as what we just talked about, which is it gives you that on-demand data fetching at the source, which makes it very cheap to get data. And it gives you this data reuse, which helps you reduce the cost and reuse computations. And then it auto-scales your resources for you so you don't have to write any of that kind of complex code. Now, with some of the challenges aside and some of the motivations and characteristics of Mantis, let's look under the hood of Mantis and see exactly how all of this works. The best way to do that is to look at Mantis from the application perspective. So if we start at the top, we have your application. These are stateless or stateful applications. Doesn't really matter, it's up to you. All that's there is they're instrumented with this little Mantis publisher client. And all this client does is send events into Mantis. These applications are external to the infrastructure. So then once you're internal to the Mantis infrastructure, there's something called a Mantis job. A Mantis job runs code that you write. All that it does is receive events from upstream and then transforms them one at a time and then produces corresponding results downstream. It produces results downstream typically to another Mantis job, or in other words, job chaining is supported natively on the platform where the input of a job can be consumed by another job and it can output to another job as well. The useful thing about this is oftentimes you might want to compute something, but somebody had already computed that. So rather than recomputing that and paying that extra cost, you just subscribe to this job that already has those results for you, and then you can get that reuse right out of the box. Now, the problem with that is that there could very well be tens of thousands of Mantis jobs. And this is code that you write, so rather than having you write complex resource management or connection management code, and rather than you inadvertently overloading those upstream applications, which we don't necessarily control, there's something called a source job in Mantis. A source job is just a Mantis job, and it comes with two different properties that are important. First is the source job's responsibility to consume external events on behalf of these Mantis jobs. And it does that through managing subscriptions. So what happens is these jobs will submit subscriptions up to the source job, and the source job will figure out where to fetch it and how, and then route them, the events, down into the corresponding jobs in a streaming fashion. So all these subscriptions are existing in the form of the Mantis query language, or MQL, surprise. MQL is just an SQL-looking thing, but with some additional verbs to help you work with event streams. So to get an understanding of how MQL works, let's look at some of the verbs that it provides. So on your left-hand side, we have more stateless, lightweight operators. And then on your right-hand side, we have more stateful, heavy, computationally intensive operators. And how this all fits into the Mantis ecosystem to get insights while minimizing costs, we can best visualize that through an example. So this query on your right side, all that it's doing is selecting a count of device errors over some sliding 10-second window, and then it groups them and then orders them. But the important thing is, let's say that we have a Mantis job that wants to submit this query. So what it'll actually do is it'll split this query into two parts, the stateless and the stateful part. It'll take this lighter weight stateless part, ship it up to the source job. The source job will register this query, and then it will propagate it up to all of the application instances. Once the application instances receive this query, then for every event that they publish, they'll evaluate them against this query and produce corresponding output, which looks like a stream of events of PS4, status 500, TV, status 500, etc. This will get sent or streamed down into the source job and then routed to the job that originated that subscription. Now, once the events reach this job, it's free to apply the second heavier part of the MQL query. In this case, it's counting, doing some windowing and grouping. And then what it'll do is produce corresponding output downstream, which is just a stream of events of error counts of PS4, count as 2, etc. Now, let's say somebody else comes along and they want to submit another query using another Mantis job on your right. What they'll do is they'll submit this lightweight query. There's only one part, so it's split into two, but they ship this part up only. This time it's asking for status 500 for PS4. They're only interested in errors from PS4. These will get sent to the source job, but now, instead of the source job going upstream to the application to refetch this data, it knows that there's already a subscriber, that job on your left, which is asking for some overlapping set of data. So it knows it has those events already, and it'll just reuse that data and send it downstream to that Mantis job. So you don't go up to the application at all for that second job, so you save on the cost there as well. The result is just a simple stream of PS4 status 500s, and while this this query in particular isn't that interesting, remember that there is job chaining, so that there very well could be another Mantis job downstream of this one, which does some more interesting computations. So to summarize this MQL section and how it gives us the insights while minimizing the costs, it does the on-demand data fetching upstream at the source. And then once events move downstream into the source job, you get data reuse and auto-scaling as well. And similarly, since source jobs are just Mantis jobs, you get the reuse and auto-scaling, again, at that tier. So up until this point, I talked about on-demand and reuse, but I haven't talked a whole lot about auto-scaling. So the best way to do that is to look at the Mantis from the infrastructure point of view. And the Mantis infrastructure can be described through this diagram. There are a few parts, API, master, etc. But the most important part we want to talk about that's relevant today is the Mantis jobs on your right, and they're run inside containers. So if we zoom into a Mantis job, you'll see that it looks a little bit like this. A Mantis job has some number of workers, and they're organized into a series of stages. The topmost stage is the source stage, and all that does is receive events from an external source, some job or another source job. It'll send that down to a series of processing stages for various transformations that you write, and then finally, they'll send it down to a sync stage to be synced out to another Mantis job. So how auto-scaling works in this case, Mantis will actually auto-scale each stage individually. So therefore, if your source is lagging, then Mantis will see these signals and it can just increase the number of workers for you automatically without you having to write any code to do that. And if you're in steady state, things are going well, then Mantis can simply just decrease the number of workers, and then you'll be good from there. Then if your processing stages start lagging, similarly, the increase can happen or the decrease as well. And all of this works for each stage independently, for each job independently as well. Now, with an understanding of how all of this works, how Mantis uses on-demand data fetching, data reuse, and auto-scaling to minimize the cost of building these types of observability or operations-focused applications, let's look at what kinds of applications have we built at Netflix. What things teams have done to help build things which help them operate their microservices much better. The first thing we'll look at is reducing downtime through contextual alerts, or MTTD. So before diving into contextual alerts, we have to first realize one thing, where if you get paged, then that means automation probably has failed you. It has failed to resolve the issue for you. So then as the last line of defense, it becomes really important that you're able to quickly orient yourself around the issue, gather insight quickly so that you can ultimately fix the issue to avoid this downtime. The best way or the typical way of starting this whole thing today is through our good friend, the trusty static threshold alert. So this is great and people still use them today, but there are gaps with this approach. For instance, you may have configured your threshold too conservatively, where you just never get paged, or you may have configured your threshold too aggressively, where you just keep getting paged all day. The other issue with that is these alerts or these thresholds are typically configured against a single metric for a single application, which means that you don't necessarily get paged for another team's alert. While this is kind of nice, it's also kind of bad because during an incident, you're not necessarily aware of whom or what is affected by this incident, and it becomes very hard to get a grasp on the situation. To better put, you have your microservice and you control your microservice. But if your microservice starts throwing errors, so will your downstream dependencies, and then so will their downstream dependencies. Effectively, you control your microservice, but in the case of an incident, you assume the responsibility of all of your downstream dependencies. And now, in this case, everybody's getting paged individually, and the pages may or may not have good descriptions, so it becomes very hard to coordinate and understand what's going on. The other issue with alerts is that it could take time to get alerted. So in your traditional systems, you might have an incident that starts, and then it takes 5 minutes for the metrics to propagate, and then eventually to be alerted. But then just to make sure that the alert's legit, that it's a real page, then you throw on a rolling count of 8 out of 10 minutes just to get confidence. This results in the alert firing 15 minutes after the actual start of the incident, and this is a 15-minute cost that you pay no matter what for this particular configuration. And that's 15 minutes before you can begin to derive any insight into the issue. What we really need is sub-second event data propagation and aggregation so that we can reduce the time to detect from tens of minutes down into tens of seconds. And then it should also be able to tune its own thresholds dynamically to account for spikiness in behavior. And then finally, it should be able to build a consolidated timeline view across many different applications. So then rather than getting a bunch of disjoint pages, you get one or few more cohesive, coherent pages. And then lastly, it should be able to figure out if it needs to detect auto-recover or itself or not, and detect whether or not it should page. So it looks a little bit like this in Mantis. Similar diagram here. These applications are actually separate. They're just microservices. There could be hundreds of them, each emitting different signals. And I've omitted parts of the Mantis infrastructure here to keep it simple. But they emit signals down into an anomaly detector job. And this anomaly detector could simply just do a streaming median estimation or some similar algorithm. But all of these signals get sent down into a contextual alerter Mantis job. And this is the thing that analyzes millions of interactions between tens or hundreds of microservices, figures out the impact, figures out who to alert, builds this contextual timeline, and then sends a page to the relevant teams, which looks something like this. You'll see there's your typical timestamp, but then you have your different services and origins that are affected. You have the issues in orange, and then the impact in pink. But the big takeaway is that rather than a bunch of teams getting their own alerts, which may not have any context in the issue, we get a more cohesive alert for them. Up until this point, I talked a whole lot about Mantis in the context of building applications which help you operate microservices. However, Mantis supports a variety of other use cases, and the one that I would like to talk to you all about today is in the space of customer support. So the typical experience of working with customer support isn't really that great. The time to understand your issue from a support staff's perspective could be quite long, or the mean time to insight could be quite high. And this is because they may be running off pre-canned runbooks, or they just simply don't have the tools necessary to help you debug your issue right there and then. It looks a little bit differently at Netflix, where people have built applications on top of Mantis, which gives our support staff the ability to derive insights very quickly and help you debug your issue right there. So more specifically, these support staff need to be equipped with things that allows them to inspect any stream at Netflix and query them in an ad hoc way. And then once they receive those events, they should be able to run on-the-fly transformations without having any latency of a redeploy or something like that. And then once they rapidly experiment and iterate on these transformations, they should be able to persist the results to some long-term storage so that they can view them at a later time. Now, to best understand this, let's take an example. Let's say you get home, you go onto Netflix, and you're having trouble playing a title. You've hit play and it just doesn't work. So you hit up customer support. What they can do is go into their browser. They'll select a stream that's most relevant to you, whatever they can get to help them derive insight into the problem. If they're not familiar with the stream, they can inspect some of the data, some of the live events that are flowing through just to get a structure of the events. And then they can build an MQL query using this simple form builder. And then finally, once they're satisfied with that query, they can submit that right into Mantis. The submission will launch a temporary Mantis job and then submit the query upstream to the source job and upstream from that, as we talked about before. If they're unsatisfied with the query or they need to iterate or explore or make changes, they can simply just terminate it and launch a new query which submits another Mantis job temporarily. So now once the events start flowing, they flow into their browser, and then they're free to transform these events right there using JavaScript without having to relaunch the Mantis job, which could take some more time. Even though the launching of a Mantis job is only a few seconds, it still ruins the experience of having to wait a few seconds for your change to take effect. Once they're done and the issue is resolved, they can simply close their browser, the query will terminate, and then the job will terminate and the data will stop flowing and the cost will no longer be paid. But in order to resolve the issue, basically what happens is these events that are flowing, they're actually your events. So what I mean by this is when you're on the line, you can go through and click, tap, and swipe through the Netflix application and then reproduce your issue right there step by step with the support staff looking at the stream of these interactions right there in real time. And then they can use this and join it with other streams, or they can look at it with the other context surrounding these events. And then it allows them to help you figure out what the problem is very quickly. So now that the issue is resolved, everything's good. And then this is the difference between a very lengthy customer support call and something that's a little bit more manageable and enjoyable of an experience. So to wrap up, today I talked about a few things. We talked about the realities and challenges of observing and operating these microservices, and how this led us to building a platform called Mantis. It's basically, there are tons of tools today that give you the ability to get insights, but the real question is, at what cost does it take to get these insights? And ideally, you should be very responsible and mindful of your costs, and kind of forecast that out based on the growth of the number of your microservices or your organization. Mantis employs a variety of techniques such as on-demand data fetching, aggressive data reuse for data and computation, and also auto-scaling as well to help you manage these costs more effectively. Some teams have built applications on top of Mantis to help reduce alerting and mean time to detect down from tens of minutes to tens of seconds, whereas you're having a more cohesive alert instead of various disjoint ones. And then another team in the customer support space has allowed you to have a more manageable on-call experience because they can see all of your interactions in real time and help you debug issues right there and then. Mantis has helped us a lot in the past and is still critical to our systems today. And while it's helped us solve a variety of operational challenges, we do believe that the challenges we face at Netflix aren't necessarily unique to Netflix itself. We run microservices, and so do other people. And for these reasons, we've open sourced it to the broader community so that others may benefit from. If any of you all have questions about Mantis or simply just want to chat about anything, feel free to send me a message on Slack or just reach out to me during the break. Thank you.
Thank you, Jeff. We're running a little bit over, so I want to get everybody out to lunch, but if we have one burning question that simply cannot wait to find or to ask in the the speaker's channel. Anybody? Wait, I'm sorry, did we have two? Did we both point to different people? All right, we're on the hook now.
So the obvious question is retention. Is there any way to get it to store 5 minutes of data so that you can stream stuff that happened from the past? Or that's not something you guys want to support at all?
That's a good question. So the question was around retention. So what if you wanted to stream something 5 minutes from the past and get insight there, or you have an even larger window of even longer than that? The answer is everything is stored in memory. So we can talk more about the trade-offs that we've more deeply about the trade-offs that we've taken. So essentially, it's in memory, and there are complications or details around that. Yep. Down there.
How do you handle access control and authorization of data so you don't have customer employees spying on customers?
That's a good question. Thanks for asking. So the question is around how do you handle access control, like isolating data, so least privilege, stuff like that. So so Mantis open source doesn't have the pluggability for that, but Mantis internally plugs into our authorization and authentication stack. But we intend to open source that pluggability part into Mantis as well, because it's a real issue, such that you have all of this data reuse and anybody can subscribe to anything, and it's great. While that's very cost effective, again, it comes at what cost, right? So it's like the cost of privilege access in that case. All right, so it's lunchtime, so feel free to reach out or send a message on Slack. Thanks.
Thank you, Jeff.